know you were there. All right, so look, the other day we did this. Let's see if I can get it behind me. All right, wow, look at that crazy math we did. All right, we've been looking at that example for the longest. We put points on a coordinate plane and we found the distance between them, okay? Today we're gonna continue to work with that, all right? But we're also gonna add one more little thing to that, and that little thing is something called slope. I've already got it set up over here. All right, we're not even gonna have to take a break. So first things first, copy that down. Let me talk through slope real quick. You like how I went off one way and came on the other? Let's talk through slope. Slope is how steep a line is, all right? If you think about every hill you've ever walked up, some of them are hard to walk up, some of them are not that hard to walk up, all right? Some of them are uphill, some of them are downhill, all right? How steep a line is called its slope. There are 4 types of slope. This should all sound familiar, all right? Zero slope. When something is flat, we say that it has 0 slope, all right? When something is straight up and down, we say it has no slope or undefined. That's a little confusing because in real life, we use the word 0 and no the same. All right, I have no dollars, I have $0. But for slope, they're different things. 0 slope means flat. No slope or undefined means straight up and down. And then there's the 2 normal types of slope we're used to dealing with, positive and negative. You read a line left to right. If it's going up from left to right, just like you read words, it's positive. If it's going down from left to right, it's negative. So, 0 slope, no slope or undefined, positive slope, negative slope. We are going to find actual slope. Slope is a number, all right? We find slope by making a fraction. Don't be afraid of fractions. And we put the change in the y over the change in the x. That sounds a little confusing. We're gonna put the rise over the run. That might sound even more confusing, but we're gonna go over to our grid here and we're going to do an example of how to find slope, how to find rise over run. It's real easy. Plot twist, you've pretty much already done it. You just didn't know you've done it, all right? So we're gonna go over here and find slope, rise over run. Let's do it. Here is our coordinate plane, all right? Remember, it has an x-axis that's flat. It has a y-axis that's straight up and down, all right? It's worth pointing out that the x-axis has 0 slope and the y-axis has no slope or undefined. It has 4 quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, and it is based around the origin where the x and y-axis meet. Let's find slope. It's real easy. Let's just put a couple points on here. Let's use orange. I was kind of digging that orange. So if I put a point right here, all right, I'm gonna call that A. And I'm gonna put a point right, I don't know, here. No, we'll put it here. No, I changed my mind again. I'm gonna put it here. All right, I'll put it here. Okay, that's exactly where I'm gonna put it. Okay, all right. Finally, I decided. Okay, so we're gonna call that B, all right? What we did the other day, if it's worth reminding, is we drew a line from one to the other, from A to B. All right, let me see how straight I can do this. That's not bad. We drew a line from A to B, and we found the distance. How did we do that? We finished the triangle. We finished the right triangle. So that right triangle, I'll finish it in, let's say, pink, all right? If I go straight down and straight over, I get a right triangle. That's kind of skinny, all right? But that's okay. So I went straight down and straight over, and I got this little right triangle. And the way we found the distance the other day is we counted the sides, and then we did the Pythagorean theorem. This was great today is that we're still gonna count the sides. We're still gonna finish the right triangle. So this right here, this side is 1, all right? I hope you can see that. It's gone up from 2 to 3 right here on the axis. It's 1 block. It would be really easy to see with graph paper. This side is 1 block, 2 block, 3 block. It's 4. All right, I'll put the 4 right here because it's a little cluttered on the axis like that. All right, so we have 2 sides. We have a 1 and a 4, 2 pink sides. All right, we have a 1 and a 4. If we were finding the distance of the purple line, we would do Pythagorean theorem. A squared plus b squared equals c squared. 1 squared plus 4 squared equals c squared. And we'd do some math. Right? You're going to do that today too. I'm just not going to go over that now. Instead, I'm going to do the Pythagorean. I'm sorry, I'm going to do slope. Slope is really easy. Slope is rise over run. What does that mean? What it means is if we want to find the slope of this line, all right, we start to the left, all right, and we say how far did it rise versus how far did it run, all right? And it rose 1. It didn't really rise 1, it fell 1. That's the 1 right there, all right? And then it running is going this way. That's 4. The point is, y'all, is that we've already got those numbers, the 1 and the 4. The rise is the vertical number and the run is the horizontal number. The rise is the vertical number and the run is the horizontal number. But here's the plot twist right here, is that this number's got to be negative. And it's got to be negative for a couple reasons. One, this purple line's going downhill. So you can see that it's got a negative slope based on what we talked about over here. But 2, it didn't rise at all, did it? It fell. It fell. If it had risen, it'd be a positive 1, but it fell, and that's a negative 1. This should sound familiar back in the back of your brain. That's why I'm not talking it to death, all right? And so I'm going to try to finish real fast right here. So we rise 1, but it's really a negative 1 because we're actually falling, all right? So that's slope. It's the same triangle. We still count the blocks on the sides, but now instead of doing the Pythagorean theorem, we just take those numbers and we put them into our slope, it's not even a formula, our slope template, rise over run. And then we have to think to ourselves, is it negative or is it positive? Well, it's negative because it's falling. All right? And that is slope. All right? It's not always the most complicated thing. Today's not even that most complicated. So I'm going to get back to work. All right? And you should get back to work too. You should get back to work too. All right. Well, see you later.